We are on to video number 8, and one more to go after this one. So we're going to start talking about some types of compounds and how to distinguish between the two main types of compounds, which are ionic and covalent compounds, and then some characteristics in this video of ionic compounds, common ions, what are called polyatomic ions, and then naming ionic compounds. So there are two major types of bonding that we're going to talk about all year, and that leads to two major types of compounds. Ionic compounds, and ionic compounds are substances that consist of ions. And what is an ion? An ion is a positively or negatively charged particle, and so ionic compounds consist of combinations of positively and negatively charged compounds that are attracted to each other, and so they bond through those electrostatic attractions. And electrostatic really means they have charges, and so their opposite charges are drawn together. And then there's covalent bonding, and that leads to what are called molecular compounds, and these are small molecular compounds consist of just small groups of atoms held together by covalent bonds. And so an example, so I'm going to show you a picture here. So this would be a picture of sodium chloride, which is an ionic compound. It consists of sodium ions, which are the purple spheres, and chloride ions, which are the green spheres. And the point of this image is to say that even though we would write the formula for sodium chloride as NaCl, which has one sodium atom and one chloride atom in the formula, the actual substance itself takes on this extended lattice form. And so the NaCl simply means that the ratio in which they combine is 1:1. What you can see is just this huge extended, and this is just a tiny picture. Obviously, a real sodium chloride crystal would just go on in every direction for much further. It's not the case that they are single sodium atoms and single chlorine atoms together as a single unit. Rather, it's this giant extended lattice of oppositely charged particles where the sodium and the chlorine are combining in a 1:1 ratio. By contrast, water, which is a molecular or covalent compound, when we say that water is H2O, we really mean that there are just little 3-atom units that have 2 hydrogens and an oxygen covalently bonded to each other, and they're different from, and then the next H2O is actually part of a different molecule, and it's not this sort of extended network of hydrogen and oxygen. It's these discrete molecules. There's a water molecule, and then over here there'd be another water molecule, and then over here there'd be another, but they're independent of each other. So for the purpose of this course, the simplest way of distinguishing that a particular compound is ionic versus a covalent or molecular is to look and see if you can find a metal, the symbol for any metallic element in its formula. And so generally, if you find anything that's got a metallic element in its formula, it's going to be ionic. And then by contrast, covalent and molecular compounds are going to be composed entirely of non-metals. And we'll talk in just a second about how to figure out what are the metals and what are the non-metals. But let me just give you some examples. KBr, which is potassium bromide, because potassium is a metal, then that's an ionic compound. It doesn't have to be made up entirely of metals, it just has to have a metal in it. So it's got potassium in it, therefore it's an ionic compound. Sodium sulfate, again, it has sodium in it. Sodium is a metal, therefore it's an ionic compound. Hydrogen chloride. Hydrogen chloride, hydrogen and chlorine, we're going to see in just a second, are both nonmetals, therefore that's a covalent compound. Diphosphorus pentoxide, phosphorus and oxygen are both nonmetals, so that's a covalent compound. Aluminum chloride, aluminum is a metal, and so that's an ionic compound. A glucose, this is the formula for glucose, C6H12O6. Carbon, hydrogen, and oxygen are all nonmetals, so that's a covalent molecular compound. Carbon dioxide is a molecular compound, carbon and oxygen both being nonmetals. Silver nitrate, silver is a metal, so this is an ionic compound. Copper oxide, copper is a metal, that's an ionic compound. Ammonia, NH3, nitrogen and hydrogen are nonmetals, so that's a covalent or a molecular compound. So this is how you would look at the formulas of these things and just make the decision about whether or not it's covalent or molecular or ionic, would be whether you see a metal in it. And the metal is always going to be the first thing. Aluminum, silver, potassium, copper, sodium. Okay, here's a periodic table. We've already talked about the periodic table in a previous video. The simplest way of knowing where the metals are is to follow this little red line that I've drawn in here. And so everything to the south and west of the red line is a metal. Everything to the north and east of the red line is a nonmetal. Don't worry about the things that are like right on the line here. These are called metalloids, and we will very rarely talk about them. But all the common metals that you're familiar with are all down in this area. Sodium, potassium, magnesium, calcium, chromium, iron, copper, nickel, zinc, silver, gold, mercury, lead, tin. These things are all down to the southwest of this metal nonmetal line. Meanwhile, the nonmetals, hydrogen, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, bromine, iodine, the noble gases here are all nonmetals. And so that's how you really distinguish on the periodic table between what's a metal and what's a nonmetal. So an ion is an atom or group of atoms that has an unequal number of protons and electrons. We actually talked about these subatomic particles in these videos, but protons have positive charges and electrons have negative charges. And if there are unequal numbers of them in the particle, then the particle is going to have a net charge. And so if we're talking about a single atom, if it loses an electron, one or more electrons, then it's going to have more protons than electrons, and therefore it's going to have a positive charge. If it gains one or more electrons, it's going to have more electrons than protons, and therefore it's going to have a net negative charge. Metals, that we were just talking about metals, all these things on the southwest of the red line, they will all, when they ionize, lose electrons, and that will give them positive charges, and positively charged ions are known as cations. Nonmetals, these, hydrogen's kind of an outlier, it can do both, but all of these nonmetals over here, when they ionize, they're going to gain electrons, and when they do that, they will have negative charges, and negatively charged ions are called anions. And so the formula of an ionic compound is simply the lowest whole number ratio of ions in the compound. So for example, that picture that I showed you of the sodium chloride, you could see that it was just this giant extended lattice, but the ratio of sodium to chlorine is 1:1, and so we write the formula as 1 sodium and 1 chlorine. Magnesium chloride, by contrast, if you were to, this is a not so great picture of a magnesium chloride crystal, but if you were to go through it, if you had a long extended lattice of this, you would find that there are twice as many chlorine atoms as there are magnesium atoms. Although again, it's not immediately apparent from this picture, but that's a different story. But in a magnesium chloride lattice, there are twice as many chlorine atoms as there are magnesium atoms, and so we write the formula MgCl2. Here is a picture of the periodic table, just showing how elements like to ionize. And so if you'll notice that here's where that diagonal line was between the metals and the nonmetals. All of these metals are forming cations, that is positively charged ions, lithium, sodium, potassium, magnesium, chromium, manganese, iron. Some of these, what are called transition metals, will form more than one ion, but you can see all the metals form cations. They all lose electrons. They all have positive charges. Hydrogen, which is a nonmetal, I mentioned it can do both. It can both gain and lose electrons. It most commonly loses electrons when it forms an ion, but it can form an H minus as well. But you'll notice that all these sort of prototypical nonmetals are all gaining electrons and are forming anions, that is, ions with negative charges. And so this is just a picture, this is just a taking of what you saw on the previous slide and organizing this into a sort of a tabular form. And you can see that the things that form cations are metals, the things that form anions are nonmetals. So how do you write the formula for an ionic compound? Well, as we've said before, ionic compounds form when a cation combines with an anion, but they don't always do that in a 1-to-1 ratio. We mentioned that for sodium chloride, it is a 1-to-1 ratio, but for magnesium chloride, it's a 1-to-2 ratio, and we can get all kinds of different ratios in which these things combine. The formula of the compound is determined by the charges on the ions. And so let's look at some examples. And when we write these formulas, we use what's called a crisscross method. And so just stepwise, what you're going to do is you're going to identify the charges on both the cation and the anion. So if I said, what is going to be the formula of a compound that forms between the sodium ion and the chloride ion, you would have to work out the charges on those two things. If the charges are the same, that is, one is +1 and the other is -1, or one is +2 and the other is -2, or one is +3 and the other is -3, then you just write the formula in a 1-to-1 ratio without subscripts. And so again, sodium chloride is an excellent example of that. If the charges are different, we're going to use the charge of the opposite ion as the subscript for a particular ion. And let me show you what that means. So let's say we're forming a compound of sodium and oxygen. The sodium ion has a +1 charge. The oxide ion has a -2 charge. Since those charges are not equal in magnitude, then it's not going to be NaO. What we do is we take the charge on the oxygen, and that becomes the subscript. Without a sign, that becomes a subscript for sodium. We take the charge on the sodium, and without a sign, that becomes the subscript for oxygen. So because oxygen is -2, we give sodium a subscript of 2. Because sodium is +1, we give oxygen a subscript of 1. And when we write formulas, we don't actually use a subscript of 1. It's just implicit in the presence of the atom there. So let's think about this one then. If aluminum is +3 and chloride is -1, what do you think the formula there is going to be? You can think about that for a second. Well, it's going to be AlCl3, because again, the charges are not equal in magnitude, so it's not going to just be AlCl. The 3, the charge on the aluminum, is going to become the subscript for the chlorine. The 1, the charge on the chloride, is going to become the subscript for the aluminum. It's AlCl3. Try your hand at this one. Calcium ion, which has a +2 charge, and oxide ion, which has a -2 charge. What do you think the formula there is going to be? Well, in this case, it is going to be CaO. We don't use the crisscross here because the magnitude of the two charges is the same. And so the +2 cancels out the -2, and they just combine in a 1-to-1 ratio. Now, everything we've talked about so far has been with what are called monatomic ions. That is, regardless of what the charge is, +1, +2, +3, -1, -2, -3, that charge is associated with a single atom. And we can even go back to here and see that these charges, whether they are +1, +2, +3, are associated with one single atom, -3, -2, -1. A polyatomic ion has a charge associated with a group of atoms. So they're essentially charged molecules. They have formulas like molecular compounds, but they also have charges. And you're going to need to know, there are 10 common polyatomic ions that you need to know, and I have got them on a sheet. There are actually 2 sheets of that contain polyatomic ions in the worksheet folder in box, but one of them, which is just called polyatomic ions, has the 10 that you need to know. And I will quiz you on this at some point early in the fall, and I'll give you I will hand out a copy of that worksheet to you as well. And so we're going to use polyatomic ions often, and so you need to be able to recognize them. Recognize that a compound containing a polyatomic ion is ionic, and that that polyatomic ion is a single unit. It doesn't break up into smaller pieces. It just basically behaves as a charged molecule. So you need to be able to recognize them quickly. And these are the 10 that you need to know, almost all of which are anions. You'll notice acetate has a -1 charge, bicarbonate has a -1 charge, carbonate -2, cyanide -1. You can see all the negative charges over here. Only the ammonium ion has a positive charge, NH4+. It is the only polyatomic ion that you will need to know about that has a positive charge. Well, how do you name an ionic compound? It's actually quite simple. You just write the name of the cation, and then you write the name of the anion. If the anion is a monatomic anion, that is, it is a nonmetal with a negative charge, it's a monatomic anion. The charge is only associated with one atom, it's not polyatomic. We change its name to ide, and so chlorine becomes chloride, fluorine becomes fluoride, oxygen becomes oxide, sulfur becomes sulfide, etc. And so here are some examples of that. If the anion is polyatomic, then we don't change its name. And so let's look at some examples of this. Here are 6 compounds for ionic compounds for you to attempt to name. Again, how do you know they're ionic? Because they're always starting with a metal: lithium, magnesium, strontium, sodium, aluminum, calcium. Pause the video for a moment, work on these, and when you think you have answers, turn it back on. Here come our answers. Lithium oxide is made up of monatomic ions, lithium and oxygen. And so we simply name the lithium and then we name oxide, again, because it's a monatomic ion, its name is changed to ide. This compound is called magnesium sulfate. If we go back a couple of slides, here's one of the polyatomic ions you need to know, sulfate. And so you need to recognize that that SO4 is a polyatomic ion. So that is magnesium sulfate. Here we have monatomic ions, strontium and chloride, so its name is simply strontium chloride, and again, we change that chlorine to chloride. Same for sodium bromide. Here you've got a polyatomic ion, the phosphate ion, and so that is aluminum phosphate. And then finally, again, here's a polyatomic ion, nitrate. When do we use parentheses with in a formula? We use parentheses when we have to give a subscript to a polyatomic ion. And so calcium has a charge of +2, nitrate has a charge of -1. When we use the crisscross method that we discussed earlier, calcium is going to have a subscript of 1 or no subscript. Nitrate is going to have a subscript of 2. So in order to make it clear that that 2 distributes across the whole thing, we put parentheses around the NO3. So there is a worksheet in the, is this the end? That is the end. So there's a worksheet in the worksheets folder that gives you practice in both naming and writing formulas for ionic compounds. There are also a couple of tables of ions, including that list of the 10 common polyatomic ions that I expect you to have memorized. Enjoy the worksheets. Don't hesitate to give me send me an email or something. I guess that's the only way you can communicate with me. Don't hesitate to send me an email if you have questions. Thanks so much.